Right, good evening, everyone. Welcome back to another session. And we're going to pick up from where we left off last week, Wednesday. All right, as it relates to the recordings, I'm having some issues getting onto the admin site. I haven't been able to get in contact with my employer. So if you haven't seen the recordings, it's because I haven't posted them. So the one from last week, the two from last week, and then this week's, the two from this week, I'll try my utmost best to try to get them up and running before the weekend. All right, so just be with me, lots of work on my side. All right, so where are we going to start? So we would have been I think tonight is an algebra night, is it?
No, sir. No, sir. Tonight, we did circle the last time.
Oh, okay. All right, good. Okay, good.
Circumference of area and perimeter of a circle.
Okay, good. So that is Monday. And
that was the 7th.
Oh, that was the 7th? Okay.
Yes.
Okay, today's the 14th, right? All right, so loading the screen. All right, so we should be wrapping up measurement tonight. Love to wrap it up. I hope everybody's doing okay. All right, so as you can see here on the screen, guys, we would have gone through a lengthy set of stuff. We'll have gone through quite a bit. See that? Some more stuff we go through. We'll look at questions and touch bases, Heron's formula. Okay, right angle triangle. What about examples to go through? Wally. Are we going? All right, so this is where we're at. Also, the last class we would have done sect and segment and arc and all those stuff, not true? So that means that tonight now we need to start volume. Not true? Tonight we need to start volume. Because we haven't started volume and we need to wrap up that tonight. All right, so we're going to go ahead and we're going to do just that. So head up for me, ladies and gentlemen, the volume of a three-dimensional prism. That's the topic for tonight. Volume of a three-dimensional prism. But I'm looking at this and it seems as if you only did like a couple of questions, right?
Yes, sir. I don't know if you should expand or what. I don't know.
I think so. I think I should perhaps
because we only did
just one
maybe
example.
one example. Yes.
Yeah, we don't usually do that. We usually do more. So, okay, I see. It seems as if majority of the class was spent on area and circumference and doing a few reverse questions. Okay, and then we touch base on sector and and length of arc. Also, we haven't touched segment. Okay, so we have quite a bit to do tonight. All right, so here's what we're gonna do. Right, we're gonna tidy up this topic here. Okay, we're gonna tidy up this topic, which is we're gonna do a couple more questions on arc and sector. And we're gonna clear up segment, and then hopefully I can get into volume. All right, so that's what we're trying to do tonight. So let's do a quick little recap. Zooming up, hold on. Okay, all right, here we go. All right, so in our last class, then I'm going to do like a quick recap here, guys. So in our last class, we would have introduced the concept of the circle, right? And as it relates to the circle, as it relates to the circle, so as it relates to the circle, oh, sorry, I need to refresh the page. Give me a sec. Give me a second, guys. Right, in our last class then, since I already have the notes here, we can just use this. Right, so in our last class, as you can see, we had introduced the concept of area and perimeter of the circle. And on screen, you're seeing all that we went through, right? We talked about the different parts of the circle, right? We looked at the fact that around the edge of the circle is called the circumference, right? And the purple line represents the diameter. The red line represents the radius. In fact, you know what? I don't even want to read from the screen. I want to draw while I'm talking. So now I'll do that. So in our last class, we would have looked at the circle. Don't know why my thing is freezing here. All right, so in our last class, we would have talked about the circle. All right, so this is giving me some issues. Hold on, Lord. Off again. Mm-hmm. I don't know what's going on with my screen. I've resetted the screen, but it just keeps giving me this. All right, so hopefully it's working now. So in our last class, we would have looked at the shape, right? Beautiful shape at that. And we would have talked a little bit about the fact that around the edge of it is called the circumference. So as I'm going around here, around the edge of it is called the circumference. And so we use the letter C to represent circumference. We would have looked at the formula that C is equal to 2 times pi times r. All right. And then inside of it here, let me see. Inside of it here, we would have referred to as the area. The inside, the middle section here is called the area, which we then use to represent which we use to represent by the letter A. So therefore, then A would have been equal to pi r squared. Now we also looked at a relationship between two lines. We looked at two lines. We said that the letter D represents what is known as the diameter. And that's basically the line that goes directly through the center of the circle. And we also looked at the letter R, which is the radius, which is basically a line that is drawn not through, but from the center of the circle. We also went ahead to look at the fact that there's a relationship between D and R. So we said that D is equal to 2 times R. And we also looked at the fact that R is equal to D divided by 2. All right. Now, we extended our knowledge now, of having done a few questions on how to find the area, reverse questions and stuff like that. We went ahead now to draw another circle. And in that circle, we then established that there are some sections of the circle that will be created. So now, when we draw a straight line through, when we just draw a line like that, right? Okay, let me just undo that, please. Okay, so when we draw a line from the center, a sec. All right, so when we draw a line, here's the center, right? Or here's the center. When we draw a line from the center to the circumference, like that, and we draw another line from the center again to another part of the circumference, it basically creates a very special region of the circle. And that region of the circle is called a sector. What I use to remember this is, as we said, it's a slice of pizza, right? So we said that sector is equal to theta divided by 360 multiplied by pi r squared, right? And we also extended our knowledge to when we find this piece around here. It's the edge right around here. I call it the crust of the pizza. So around here, we refer to this green section here as the arc. And the arc then is going to be equal to theta divided by 360 multiplied by 2 pi r. Now, we also mentioned the importance of understanding this symbol here that we have, this symbol that is called theta. Now, theta is a symbol that we use to represent an unknown angle. So where do we find theta? Theta is going to be given to you. So inside here, you would refer to this as the minor theta or the minor angle. And then on the outside, we would refer to this as the major angle. So the angle on the outside here is major, and the angle on the inside here is minor angle. And if you're going to calculate the area of the minor sector, you're going to need to use the minor angle. And if you're going to find the area of the major sector, you are going to need to calculate using the major angle. All right? So if we were to just kind of go back up here and look back at our notes that we have, you can see that what I've just done here is a summary. Up here will give you a much more structured version of what we did right here. So you can see that we were talking about sector, the yellow part, segment, the blue section. We looked at D and R, we looked at circumference, and that's what we did in our last class, right? So what I'm going to do now is that usually I have more examples than this, so I'm going to run you an example of how we actually work this out. All right, so pay close attention then, guys. Here's my circle. Lovely. And then I'm going to draw, that's the center of the circle. That's my radius. That's my radius again. All right, sorry for the line going on the outside. I'm so sorry. Here.
Excuse me, sir.
Yes, go ahead.
You have students in the waiting room.
I do? Oh my. right, so now what I'm going to do, let me just try to zoom up a little bit more so you guys can get a better view. Good. So now I'm going to place a measurement here. Now pay close attention to what I'm about to ask you to calculate. So I'm going to place an angle right in here, and I'm going to call this angle 80 degrees. No, I did 80 last time, not true? Let's call this angle 65 degrees, right? I'm going to place a measurement here. I'm going to call this side 9 centimeter. Now, to be very specific, what I'm going to do is that I'm going to label the center as O. I'm going to label the two edges here, or the two vertex, as P and Q. And I'm going to put a little spot up here. Up here, so I'm going to put a little spot, and I'm going to call it R. All right, so there's a spot on the circumference, R. All right? So now, the question then they're going to be asked is, let me just grab a little notepad here. Given that the diagram below has a radius of 9 centimeter and question? Okay, given that the diagram below has a radius of 9 centimeter and a central angle of 65 degrees. I don't have a degree symbol on my phone. So let's call it degrees. 65 degrees. 65 degrees. Calculate the following. And here's what we're going to calculate. 1. The area of OPR Q. That's 1. 2. The length of PQ. The length of PQ. And I'm going to go ahead and add in something here. 3. The area of the segment. So I'm going to move this here. All right, so we're going to move it to the side here. All right. Good. And then now I'm going to go ahead here and draw another line right here. Now, for the purpose of learning, I'm going to shade the segment in green. So number 3 question where I said that you should find the area of the segment. I'm asking you for the area of the green section. So we're going to look at these 2 questions then. All right. So for number 1 then, we're asked to find the area of OPRQ. So how do we find that? Now, if you look carefully, right? If I touch, let me just see if I can grab a cursor here. Now, if you look at this, guys, this is O, this is P. So look at the kind of shape that it forms. Watch my green line moving. This is O right here. So look at the shape that it's forming now. O to P, all the way to R, and come back all the way around to Q. Basically, we are finding the area of the major sector. That big empty white space up there, so. Right? So if you draw the line, O to P, come all the way around to R, and then slide, come back around to Q, you end up with what is known as the major sector. So therefore then, we will need a sector formula. So the sector formula, if we can grab it from the last class, area of sec is equal to theta over 360 multiplied by pi r squared. Now, in this case, careful that you don't use the wrong theta, because when you look at the diagram, you're seeing 65. But remember, we told you last week, that if you're finding the minor sector, you need to use the minor angle. And if you're finding the major sector, you need to find the major angle. Now, this angle right here is a very small angle, 65. So that means we can't use that 65 because we're finding the major. We've established that OPRQ is the major. So therefore, to find this theta is going to be equal to 360 minus 65. So therefore then, the area of the sector we're trying to find is going to be equal to 295 divided by 360 multiplied by 3.142 or 3.14 times 9 squared, because the radius is 9 and we're going to square it. So you can go on your calculator then and go ahead and type in all of that and tell me what you get. Anybody got the answers yet?
I got 208.41 or 42. You can square it off the 42.
Squared centimeters. Good.
I get well, I get 5.
Yeah, man, it's fine. The decimal not gonna make much of a difference. Price of rice not gonna change. All right. Now, that would be the area of the sector that they ask us to find. Now, pay close attention to this question now. The length of PQ. Now, PQ can be interpreted two ways.
Yes, sir.
Yes, go ahead.
I get 205.69.
Well, maybe I'll just check it in, because some get 205, some get 208. That can't write. So maybe I'll just check it for myself then. I'm typing on my calculator. I can see it here. 295 divided by 360 multiplied by 3.14. I hope you don't add on the 2, times 9 times 9. I'm getting 208.41, which basically round out to 208.42. So double check that again there. Maybe you made a mistake somewhere. Maybe you press a number by accident.
3.142.
Maybe you should use the 3.142.
Sir, why shouldn't we use the 3.142?
It's not why. I think it's better to use the 3.1. It's better to use the 3.14. The less decimal point you use, is the more inaccurate your answer is going to be.
Okay.
So it depends on what they tell you to use. But traditionally, 3.14, 3.142, we mark for an answer that is within a range. So we would still give her the correct answer as 205 point whatever if you use the 3.142. All right. So now the next question says, guys, find the length of PQ. So the length of PQ can be interpreted two ways. Now pay attention to PQ. PQ can be from this distance to this distance right here, which is the red line at the base. Or PQ can be equal to this curve around here. So the question then lies, which one are they asking me to find, Mr. Peart? If they wanted you to find the red PQ, they would say find the length of the chord. They would specify and say the chord. When they don't specify and say find the length of the chord PQ, they have to say find the length of PQ, the chord. Or they'll say find the length of the chord PQ. Then that's when you would find the red one. Otherwise, if they just simply say find the length of PQ, you have to assume that it's the curved black line that you're trying to find. And as you can see here, the curved black line is actually an arc, right? It's an arc. We would have discussed that last week. The arc is the crust of the circle or the crust of the pizza. So therefore then, using that information, we can confirm that the length of arc, so L arc, so L arc, oops, sorry guys. Oh, my page wants to refresh again. Hold on. All right, so we're back. Hopefully. So L arc, or so L arc means length of arc, is equal to theta divided by 360. This time we're going to multiply it by 2 pi r. And that's going to be equal to, now, which theta are we going to use? If you notice that PQ, the arc PQ is the small one, because PRQ, this one over here, this one all the way around here, is going to be the large one. This one is going to be the large arc. We want the small one. So now we're going to go ahead and use the 65 divided by 360. And this time we're going to times it by pi r squared. Sorry, by 2 pi r. My apologies, guys. Then the times it by pi r squared. Sorry, 2 pi r. Okay, so 2 pi r is going to be 2 times pi, which is going to be 3.14. And the radius is going to be 9. All right, so you guys can go ahead and process that for me. I'm going to verify based on what you tell me. So I'm currently going ahead and typing it into my calculator. 65 divided by 360 multiplied by 2 times 3.14 times 9. Are you guys getting 10.205 or 10.21?
Yes, sir.
So therefore, the distance from here all the way around here, the distance of this curve right here, so is 10.21 centimeter. Round it off, okay? All right, good. All right.
Okay, so sir, so for the major arc, you use the theta over 360 times pi r square, and for the minor.
No, for the sector, we times it by pi r square. For the arc, we times it by 2 pi r.
So what did we? Okay.
We found the area of the sector first. What we just did was found the length.
So that was
the
the sector. Okay.
Right,
Okay.
right.
All right.
So that's why the formula has a slight difference.
Okay.
So you can see sector, pi r squared. Arc, 2 pi r. All right. So then the next question was this one, the area of the segment, which we didn't get a chance to do in the last class. So the segment now. So here's the formula for the segment. Unfortunately, unlike the first two that I just gave you, which comes on the exam paper, the segment is more like an intuition thing. Well, not intuition, because intuition doesn't work. You have to know where you are the same way. So for the segment then, pardon me, let me just bring this up here. So for the segment then, so we're going to call it A seg. A seg, because we have A sec, L arc, and A seg. So A sec is area of sector. A seg is area of segment. So A seg is going to be equal to A sec minus A tri. So area of segment is going to be equal to the area of the sector minus the area of the triangle. So the area of the segment, and bear in mind, you have to be very mindful of which sector you're using. The question then can set up tricky, you know. So you have to watch what you do. You have to remember, if you found the major segment or it's the minor segment you're finding. So you have to really think, right? Depending on the question structure. All right, so let me reason with you now. Let me zoom it out a little bit. Remember the segment that we found, ladies and gentlemen. What we found first, right? Let me highlight it for you here. What we found first here was the area of the major sector. What we are trying to find here is the area of the minor segment. So focus with me now. Don't lose me. We calculated the area of the major sector. But we're trying to find the area of the minor segment. So get which sector we're going to need down here. So we're going to need the area of the minor sector down here. So we can't go use that number here where we have up here, so, because that is major. We can't use nothing major if you're trying to find something minor. Everything has to be correlated. So for this particular example, which is a tricky one, that's why I would give you 3 marks for it. You'd have to read the question and realize that, Mr. Peart, I have to go ahead and find the area of the minor sector because I want the minor segment. Okay? So we're going to go ahead and do that. So for this one now, we're going to go ahead and say for the A seg, right? The new A seg. Sorry, the new A seg, pardon me. For this one right here, we are going to need to use theta over 360 times pi r squared. So just in case some of you might be asking, sir, you just do it a while ago. Why not just use the answer? Because the theta I'm going to use now is going to be 65 over 360. And I'm going to times it by 3.14 times 9 squared. All right, so go ahead and process that for me. $65 divided by 360 multiplied by 3.14 times 9 squared. I'm getting 116. So here now I'm getting 116. .57. So that's the area of the sector, right? That's the area of the sector. Now, the triangle now, we need to find that. Now, give me a second. Somebody is asking for a Zoom confirmation. But this person is late. Lord.
Sir,
Yeah.
you said 65 over 360 times 3.14 times 9 squared.
That is correct, yeah.
And what's the answer you got?
I got 116.57. You didn't get that?
45 point
Yeah,
9.
45, may I see?
And that may I get too?
65. Could be my mistake, so I double check. 65 over 360 times
Okay, that was
3.14 times 9 times 9. Oh, my bad. It was my mistake. Thank you.
All right.
All right, so you guys corrected me. The answer is 45.92. All right, and then this is going to be minus now. Area of tri. Area of tri means the area of the red triangle. So you have to find the area of the red triangle. All right, so the area of the triangle now, right? Remember, we would have looked at. Let's see if we can zoom back. Right, we're gonna scroll up back to that page that we would have looked at the area of triangles. Let me see if I can go all the way back where we discussed that. Okay, all the way up here. All right, there it is. Good. So we would have looked at two different formulas, right? We would have looked at this formula here. Half base times height. Not true? That's the area of a right angle triangle. We would have also looked at the Heron's formula, which is the area of the triangle when you get all three sides. And if none of those formulas work, if none of them work, then we can look at finding the area of the triangle by using the last formula that we discussed here. Look at it at the bottom. Did we look at it? Oh, yeah, here it is, right here. AB times sine theta divided by 2. So that's the area of a triangle when we have two sides and the angle between. So let's scroll back down to where we are at here, down here. So that's the formula that we're going to grab right here. So the area of this triangle right here that we're looking at is going to be equal to. So the area of the tri is going to be equal to A times B times the sine of theta divided by 2. In this case, A and B, let's zoom back up here. A and B are going to be the two sides that we have here, 9, and we also know that is 9 as well. Because it's a radius, so both sides are equal. So it's going to be 9 times 9 times the sine of 65 divided by 2. Now there is a button on your calculator that says SIN. You should see one that says COS, and you should also see one that says TAN. So go ahead and type for me 9 times 9 times the sine of 65, then press equal. Remember to press equal, you know. 9 times 9 times SIN, sine of 65, press equal, and then press divide by 2. Are you guys getting 36.7?
Yes,
Yes,
sir.
Yes, sir.
All right, and then you go ahead now and you subtract those two. So it's going to then now be 45.92 minus 36.7. And so the answer for that red section is going to be 9.2. 9.22 centimeter. All right. So, I mean, I can go in class, I can work several of these and then 9 of them on the exam. I just give you a good idea of, how to approach it when you get a chance like that. You have to be very careful of when you're working it. But we're going to see lots of these, like I said, right? We're going to see lots of these popping up in our practice sheets. We're going to see lots of these popping up in our extra class and workshops. So don't worry about it. Whatever you catch, right? But you'll see it again. This won't be the last time you'll see this. All right. So that wraps up that topic. Okay. So we have 3 formulas that we need to write down, right? Well, we had 2 from last class. So this one that we have in red here, ladies and gentlemen, make sure you have it. Area of seg is equal to area of sec minus area of tri. All right, make sure you have that. Remember, guys, you see, when you join the class late, there's a high probability that you might not. There's a high probability that you might be late into the class later. You miss half the class. Okay. Remember, an online class is just like a face-to-face class. You're late, you're gonna miss out. All right, because when I'm teaching, I can't stop to check if somebody's in the waiting room. All right, cool. All right, lovely. So we would have wrapped up that section of the circle. Now we only have one thing left to wrap up now.
Sir, can you just
Before, and I don't think that. Yeah.
Sir, can you?
I'm not hearing you. Say, sir, can you what?
Put it up so I can take a picture.
Okay. So area of seg is equal to area of sec minus area of tri. Remember that the segment and the sector, whichever, are the same formula you're using now. Are the same formula I use. It just depends on the angle that you're using. So if it's
slide it, go down.
Pardon me?
Go down. Let me
There's
get the
nothing more
top
down there.
area. No, the top area. Let
so
me
you
get
mean.
the top area. Yes.
Okay. All right.
Thank you.
Welcome. So essentially, what is it that I want to do? So regardless of wherever we stop tonight, I'm not coming back to this topic next week. Anything that we don't catch on to, we'll catch on to it in a worksheet, right? But we will have the tools to help us in those worksheets. So I'm not going to leave you stranded. Okay? So what I want to essentially talk about tonight, right? Yeah, so that's what I want to talk about. I want to talk about something called volume. And a synonym for the word volume is capacity. Assuming that you know that when something has a capacity, it has space. So volume / capacity. That's what we want to talk about tonight. Now, when we talk about volume, what we're referring to is the amount of space that something can hold, an object particularly, right? And the objects that we're talking about, I'm going to list them shortly, right? Is, for example, anything that you can hold in your hand and you can feel it would be an example of a solid, right? So your phone is an example of a solid because you can hold it in your hand. The mug that you drink your morning cup of coffee or your morning cup of tea in is a solid. A football is a solid. The cornflakes box is a solid. The tissue is a solid. There are several solids that we're going to be exposed to tonight in the next half an hour, right? I'm not trying to teach too fast, but I'm not trying to go too slow either. So when we talk about volume, let me just drop down the definition here. All right, so volume is defined as the total capacity that a solid can occupy. Volume is measured in cubic units. So as opposed to writing down the answer and saying the answer is cm squared, we're going to instead write down something like cm to the power of 3, something like that. Or it can be measured in what is referred to as liters. So those are the two units that we're going to be using throughout exposing you to this thing here, right? So volume is defined as the total capacity that a solid can occupy. Volume is measured in cubic units. All right. Now, we're going to be exposed to several types of solids, to which I'm going to draw for you shortly, right? Now, we have a formula for this, right? Very simple formula, 3 letters. Volume is going to be equal to A multiplied by H. So volume is equal to A multiplied by H. Now, what I encourage all my students over the years that I've been teaching is to ensure you understand that if I ask you right now, what does A represent? I'm sure everybody in you is going to guess. And you're, of course, going to guess right and say that the A stands for area. Here's the challenge with this now. It doesn't just stand for area, but it actually stands for the area of the cross section. Let me see if I can write this a little smaller. All right, so A stands for the area of the cross section. And we already know that V stands for volume. And assuming that you guys would obviously make a wild guess and say that the H stands for the height. All right? Yeah. Now, right below height, I'm going to put another word here. And in a second, I'll explain to you why I put that word there. Okay? Just give me a few. I'm going to put length. So the formula can be V equals AH, or it can be V equals AL, A times L. You'll understand what I mean by length and height shortly. So the next question you probably have to ask me is, all right, sir, so A stands for area of cross section. But what is a cross section? I don't know. I've never done math in my life. I'm not a math person. So you need me to explain to you what is a cross section. Now, a cross section is more put it simpler. Because when you look it up online, it does have this complicated explanation when it's far simpler than that. Especially at this level, it's way simpler, right? A cross section is basically the two identical parts of the solid. So I'm still not understand. Two identical parts of the solid. Let me show you what I'm talking about. So pay attention to the diagram I'm drawing on screen. You don't have to draw it, guys, because you can always find these on Google, right? So pay attention to the diagram I'm going to draw. No, I want to draw it neater than that. Hold on. I want to draw it neater than that. Give me a second. That is an example of a solid. This solid is called a cube. So how is it or why is it called a cube, Mr. Peart? Well, it's called a cube because every cube has what is called a square cross section. And so the cross section is basically at the top and the bottom of the solid. So to simply put it then, the cross section is going to be at the top and the bottom of a solid that is standing up. Now, imagine you put a mug on the kitchen counter, right? What kind of shape does the mug have at the base? Anybody? What kind of shape does the mug have as the base? A traditional
Circle.
mug. A circle, not true. And what kind of shape is the opening of the mug where you pour the tea, where you drink the tea out of? What kind of shape is that?
Also a circle.
Circle as well.
Also a circle. Very good. So therefore, a mug, which is a perfect example of a cylinder, which you're going to see shortly, the cross section of the mug is a circle. And if you notice that the mug has two cross sections at the bottom and also at the top, right? Very good. So this is called a cube because the cube have what is called a, ooh, what is that, Mr. Peart? All right, so the cube is called a cube because it has a square cross section. All right, so that's why it's called a cube because the cross section of the cube is a square. Now, a perfect example of a real life cube would be, for example, a die. You know that thing that we shake and play Ludo, Ludi, that die something there? That's a perfect example of a cube. Or some person will say, sir, one box is a perfect example of a cube. Yeah, you have different type of box. Okay? You have flat box and you have square box. So, I don't use the word box. I will just use the word die. A die is a perfect example of a cube. Okay? All right. Now, the next solid that I want us to look at is the solid known as a cuboid. And so this is how you draw the cuboid. that's an example of a cuboid. It's a little bit like the cube, but it's more flat and more elongated. A perfect example of that would be like a watch box, a cornflakes box, your dresser drawer would be an example of a cuboid. Your cellular phone would be an example of a cuboid. Drawing on screen, you can see there. All right. So then where's the cross section? Again, the cross section is at the top and the bottom of the prism. Now, depending on what paper you're doing, sometimes depending on the orientation of the diagram of the solid, because some textbooks will tell you, right, that the solid, the cross sections at the side and the side, and it's not incorrect, because the cross section can be at the side and the side, but it's only at the side and the side when the solid is lying down flat on the belly, right? So that's when it's at the side and the side. Otherwise, the cross section of a prism, or so a prism is another word for a solid, right? So the cross section is always at the top and the bottom most of the time. Okay, so now again, this is called a cuboid, pardon me, C. And the reason why it's called a cuboid is because the cross section is rectangular. So it has a rectangular cross section. Okay, so that's why it's called a cuboid. Now, the next solid that I want to share with you all right, so the next solid is going to be the solid of a cylinder. So I'm going to go over here. I'm going to draw my cylinder over here. I don't know what is this. Lord have mercy. What is this, though, Lord? I was trying to get an ellipse, but it's not working out. Sorry, guys, I got kicked out. Are you guys hearing me?
Yes, sir.
All right. Sorry, I got kicked out a while ago. All right, we're back. All right, so I think you all lost me about here. Did you guys hear me up until this point?
Yes. Yes.
Yes, sir.
All right, good. Thank you. All right, so the next solid then that we want to look at is the solid cylinder. All right, so here we go. In a draw perfect, you get the idea. So that's the cylinder, right? And the cylinder could be a water bottle, right? Like water, catching peak. But those are what we call irregular cylinders because the cork is smaller than the base. So we call it an irregular cylinder. But this is a way you call a regular cylinder where, as you can see, that the cross section is circular, top and bottom again, and here at the bottom. Now, what I was saying to you earlier was that you can have a you can have a solid with the cross sections at the side and the side. So it depends on if the solid looks like this. So now you have to say that the cross section is at the side and the side. The point is that when it comes to the cross section of a solid, there has to be two of them. There has to be two identical shape. So in this case, then, for that cylinder, it's at the side and the side. So why do we call this a cylinder? Well, we call it a cylinder simply because the cross section is a circle. So that's why it's called a cylinder. Okay. Now, the next solid that we're going to look at is the solid of a triangular prism. We're going to move up here. So the triangular prism. Now, the best example I can give you for a triangular prism is a football goalpost. If you know what one football goalpost look like, then you have successfully identified a triangular prism. Let me draw one for you. So that is what we call a triangular prism. And again, as you can see, this triangular prism has a right angle triangle as its cross section. I'm going to ensure that I put a little red marker down here. That's 90 degrees here, and that's 90 degrees there. All right, so that would be the triangular prism. I don't know why this is freezing. Come like the computer tired of me tonight, you know. Because no, it's freezing again. You know what? I'm not going to use this screen. I'm just going to use the whiteboard that is on Zoom. I don't think that one is. That is wasting a lot of time. Valuable 5 and 10 minutes just to reset the board. So I think I'm going to change my board next class. This app is just not working for me. All right, so that's the triangular prism, ladies and gentlemen. And as you can see right here, this is the 90-degree angle, and that one's a 90-degree angle as well. Right?
I'm not seeing your screen.
Okay. See it now?
Yes, sir.
All right, so good. So that would be the triangular prism right there. And you can see there's a triangle at the side. Now, there is another version for this, which you need to look out for. I'm going to draw it for you. All right. So that's another version for the triangular prism. And as you can see, this time the cross section is a triangle, but it's not right angled. It's just a regular triangle. Now, the next prism that I want you to look at, remember, prism and solid is the same thing. So the next prism that I want you to look at is going to be well, apparently, guys, I don't know, for some reason, this item will give me some problem tonight. So you know what? I'm not going to stress it. When we come next class, but it a freeze every second, so I don't know what this is. So when we come next class, I'll finish drawing the solids and run through a few questions. But we're definitely starting a new topic next week. I'm thinking that we're gonna start trigonometry next week, okay? So we're gonna start trigonometry next week because after measurement, I usually transition into trigonometry. I might change my mind, but for now, I think I have that because I think the class before this one, I taught them trig. So I don't want to teach trig twice. So I might do trig, or I might just do geometry. All right. So in our next class, what I'm going to do is that I'm going to finish up the solids and come with a couple questions. I'm going to just, rather than come here and teach it, I'm just going to come with a worksheet that has something about the solids that we can work out for the first hour of the class. And then for the last hour, we introduce the new topic. Okay? But for now, guys, my device is freezing, so I'm going to end the class because I'm getting annoyed. All right? Have a good night and a good weekend, and I'll see you guys next week.
All right, good night, sir. Bye.
Good night, sir. Good night, everyone.
Night, sir.
Everyone.
Good night.